Alright, welcome back to Mr. PL's with Algebra 2. This is Unit 1, Topic 3, SLT number 19. So we're going to talk about squeezing down numbers when we're solving exponential equations. We're going to start off with some exponential equations that work out perfectly. 2 to the power of x is equal to 2. Now, 2 is the same as 2 to the first power. Now, once the bases are the same, we can cross them off, and the exponents must also be the same. So x must be 1. So these bases are already the same, so then x, cross off these bases, and then x must be 3. These bases are not the same, so I want to change the base to make them the same. 16 is the same thing as 2 to the 2, 4, 8, 16. So that would be the fourth power. So I multiply 2 by itself 4 times to get 16. Now that I've got bases the same, I can cross them off. X must be 4. Alright, so same thing goes with this one, but I'm going to need to move the equation. I'm going to move this over to the other side. So I'm left with just 2 to the x equals 64. 64 is the same thing as 2 to the 2, 4, 8, 16, 32, 64. So that would be 2 to the 6th power is equal to 2 to the x, so then x must be 6. Alright, so this one's plus 1 on both sides, so 2 to the x power equals 1. And 1 is the same thing as 2 to the 0th power, so that means x must be 0. Alright, for this one, 64 is 2 to the 2, 4, 8, 16, 32, 64, like we said, so that's 6th power. 2 to the 3x. Okay, so now we cross off the 2's and we got an equation. 3x equals 6, which means x must be 2 once I divide both sides by 3. Alright, 32 is the same as 2 to the 5th power, and this is 2 to the x plus 1. Cross off the bases. We have x plus 1 equals 5, which means subtract 1, which means x must be 4. Now, all of these questions worked out perfectly because all of these numbers, like 32 and 64 and 16, they could all be changed to base 2. So this lesson is about, well, what if it can't be changed to base 2? Then what happens? So we're going to like squeeze it down to find the closest number that we could possibly find, because it's an irrational answer. It would go on forever. So in this case, the bacteria grows at a rate of once, it doubles every single day. So after one day, it's one bacterium right here. After 2 days, it'd be 2 bacterium. After 3 days, it'd be 4. So now these are multiplying by 2. After 4 days, it would be 8. And after 5 days, it would be 16. So clearly, this is exponential because it's got a geometric pattern. It's being multiplied. What function? So this would be y equals a starting point of 1 times a rate of 2 to the power of x. So 2 to the power of 2 is 2. I'm sorry, 2 to the power of x minus 1. Sorry, it started with the first day. 2 to the power of x minus 1. So 2 to the power of x minus 1 is 1. 2 minus 1 is 1. 2 to the first power is 2. X, which is 3. 3 minus 1 is 2. 2 to the second power is 4. Roughly, how long would it take the population to reach 10? Now, it would take between 4 and 5 days. So this means that x would have to be between 4 and 5. Now, next thing I want to ask is, well, which one is it probably closer to? Is it closer to 4 days or is it closer to 5 days? Well, if it's 10, 10 is closer to 8 than it is 16. So I probably would say that the underestimate is closer. And that's what today's lesson is all about, finding the estimates based upon whether the underestimate or the overestimate is closer. To determine the value of 2t equals 10, what is the underestimate of t? Okay, so I basically just answered that question. All right, so can we find a better answer to this question? Now, if 4 is closer than 5, so then I'm going to test numbers like 4.1, 4.2, 4.3, 4.4, and 4.5. Now, when I'm doing that, the reason I know I'm going to test these numbers is because these are all the numbers that are closer to 4. If I do 4.6, that's closer to 5, but I know it's going to be in between one of these numbers. So I need to do 2 to the 4.1, 2 to the 4.1 power. Oh, I need to turn it on. 2 to the 4.1 equals 17.14. 2 to the 4.2. 2 to the 4.2 equals 18.37. So we're getting closer. Okay, what was the original number again? We're looking for 10. 10 is between the 4th day and the 5th day. Oh, because it's x minus 1. Okay, so you know what? I need to start over, and I need to just take into account that we are starting after 0 days. I put 1 there first, and that's kind of throwing everything off. So 1, 2, 3, 4, 2, 4, 8, 16. So that means it's actually going to be between the 2nd and the 3rd day. Okay, so that's going to change my equation here. So that means it's going to be just 2 to the x power, not 2 to the x minus 1, which would have worked. Okay, it does work if you change this to 1. There's nothing wrong with what I did earlier, but I'm changing it to 0th day. So I'm saying at the very beginning, it hasn't been any days whatsoever. It's not the 1st day, it's the 0th day. Okay, so then we know the answer is between 2 and 3, right? No, it's not. It is between 3 and 4. 10 is between 3 and 4. All right, because it's between these two numbers. 10 is in between, and it's still closer to 3. Which changes all these numbers to 3.1 and so forth. 3.1, 3.2, 3.3, 3.4, 3.5. Okay, so trying this again. 2 to the 3.1 is 8.57. That's still too low. We want to get to 10. So 2 to the 3.2 is 9.18. We're getting closer. 2 to the 3.3 is 9.8. Now we're getting really close. 2 to the 3.4 is 10.5. Okay, so now we've gone over. So it looks like this is 0.5 away and this is only 0.2 away. So it looks like 0.3 was closer. So if I'm going to keep squeezing it, so that would be 2.31. Okay, why did I write 3.31? So 2.31, 2.32, 2.33, 2.34. Now I know it's going to be in between one of these numbers because, like I said, the underestimate was closer than the overestimate. 10 is between 3.3 and 3.4. So I could keep the process going. 2 to the 3.2 points. I keep doing that. 2.31. Oh, it is 3. 3.31. Man, I'm making a bunch of mistakes, silly mistakes on here. So let's try that again. So it's going to be 3.31. All right, 2 to the 3.31 is 9.91. Okay, so I'm pretty close already. 2 to the 3.32 is 9.98. That's really close. 2 to the 3.33 is 10.0. So 10.056, so forth. So this is 0.2 away. Actually, 0.02 away. This is 0.05 away. Yeah, we've gotten very, very, very close. I could keep doing this. Honestly, I could keep doing this forever and keep getting closer and closer and closer and closer. But it's going to be an irrational answer, which means we could do this forever and never get exactly 10 as the answer. The calculator is going to run out of spaces, so it might think it's at 10, but it's actually not. So that's basically the premise of this. And I'm going to just do one more. So basically you're doing the exact same thing. So 2 to the what power is 1,000? So you just kind of have to guess at it. So 2 to the 5th power is only 32. 2 to the 10th power is 1,024. So we know if 2 to the 10th power is 1,024, we're getting pretty close. That means that x must be between 9 and 10, but much closer to 10. So x must be between 9 and 10, but much closer to 10. So the overestimate in this case is closer. So now we'll go to 2 to the 9.9. I'm going to squeeze it as much as I possibly can, which is 955, which means it's above that. So we could take that even a step further. Let's go to the hundredths place, which is what the directions say to do. So we could say 2 to the 9.98, which is 1,009. So I want to go a little bit lower. 2 to the 9.97. 1,002, getting closer. 2 to the 9.96. 995. So it looks like 2 to the 9.97 is as close as I'm going to get to the nearest hundredth. All right, I'm going to keep this short because in the grand idea of everything, so this is basically just getting you an idea of why we're going to do logarithms, because now you're going to see that, okay, this is not exactly an easy process. There is a much easier way of finding the exact answer in the calculator, which you're going to see in the future. All right, please give a like if you learned something about squeezing these irrational numbers to solve the equations, and subscribe if you haven't done so already. Thanks again for watching.